we've got a lovely geometry problem here. A cylindrical tank, 8 feet diameter, 12 feet height, is filled at 15 cubic feet per minute. How long to reach 80% capacity? Let's analyze this problem and make some sense of it. My goal is to figure out an amount of time. Okay, so my ultimate goal is to calculate the time needed in order to reach this 80% capacity. Well, then I guess I need to know the 80% capacity before I can calculate the time. So before I get the time, I'm going to need to get the 80% capacity. Well, 80% of what? In order to figure out 80% of the capacity, we need to know the full volume of the cylinder. So by working backwards, I've already established a little bit of a plan. Calculate the volume of the cylinder, find 80% of that, and then find the time needed to get to that volume. So to calculate the volume of a three-dimensional object, we're going to need a formula for that object. The formula for the volume of a cylinder, we can look up, and it's the volume is equal to pi times radius squared times height. So what information do we have in our word problem? Well, we do have the height, which is 12 feet, but we don't have the radius. We have a diameter, but that's not the same thing as a radius. We want a radius, but we know that the radius is just half the diameter. So I can think of this as a 4-foot radius. All right, so I have all the information I can plug into this equation. So my volume is going to be equal to pi times the radius squared, that's 4 feet, times the height, which is 12. And that's going to be approximately 603 cubic feet. I'm rounding here because I don't have time to write infinite decimal places. So we're going to call this about 603 cubic feet. Fantastic. So now I need to find 80% of that. Well, 80% of a quantity we can think of as 80% times that quantity. So 80% of 603 is going to be 482.4. Groovy. Finally, we need to calculate the time needed to reach 80% capacity. What we know is that it fills at 15 cubic feet per minute. And we want to know how much time it will take to do 482.4 cubic feet. One way that we could think of this is with proportions. We know the rate is 15 cubic feet for every 1 minute, and that's got to be proportional to our volume, 482.4 cubic feet, by some amount of time. I've now set up a proportion. 15 over 1 is equal to 482.4 over x. We can use the strategy of cross multiplication. So x times 15, we've got 15x is equal to 1 times 482.4, which is 482.4. And now we've got this lovely little pre-algebra problem solving for x. We can divide both sides of the equation by the coefficient, divide both sides by 15. So 15x divided by 15, the 15s cancel into an invisible 1, and we have just x. And then we've got x is equal to 482.4 divided by 15. I do this division out, and I'm going to get approximately 32. In fact, I've been rounding a lot in this problem. I think that I really owe it to myself to use approximately equals to. So by following these steps of the plan we made, we've got x, the amount of time, is equal to about 32 minutes. Hope this helps.